set yourselves up for an incalculable catastrophe of outstanding extent. Below, the red Goliath star, adjusted on the edge of our framework, is passing on terrible messages through the universe. Using the James Webb Space Telescope, cosmologists have revealed something essentially fomenting about this gigantic brilliant body. As famous astrophysicist Brian Cox gives a grave admission, the question looms: are we on the grade of seeing a shocking infinite blast imp that could everlastingly change the night sky? To the extent that we may be concerned, we ought to make a dive into the astonishing weaved craftsmanship of the universe, where stars are imagined, live, and pass on in amazing plan. One star has actually gotten the imaginative mind and stress of cosmologists and the public alike. This star is below, a red very Goliath of monstrous extent and age, situated noticeably in the grand body Orion. Its obvious bronze color and variable magnificence had for quite a while been a wellspring of interest. However, progressing upgrades have reinforced interest in this sublime beast. As we research the possibility of below, we end up on the cusp of a perhaps incredible event in the present example of the star. Regardless, what could these movements in below anytime suggest? Might it at some point be said that we are seeing the prelude to an endless showcase of unimaginable scale? ALU, generally many times greater than our Sun, is a heaven behemoth. Its tremendous size is almost outside human capacity to get a handle on. Imagine a star so colossal that were it to displace our Sun, its surface would extend beyond the orbit of Mars, overpowering Mercury, Venus, Earth, and Mars in its brilliant embrace. This is not only a show of below's true characteristics, but also represents its stage in the imminent life cycle. As a red super Goliath monster, below is in the dusk of its presence, a phase described by development and cooling following a life spent merging hydrogen into helium in its middle. However, what about the hour of below? This star, believed to be around 8.8 to 8.5 million years old, is mostly young in human terms yet ancient with respect to magnificent lifetimes. It's as the two continuous red very Goliath stage perfection of millions of extended lengths of glorious improvement, a period set apart by close to personal changes and cycles that have transformed it from a hot blue star to the red Goliath we see today. The present example of stars as is below is a record of progress driven by the consistent powers of nuclear fusion and gravity. B's indisputable ruddy shade is another indication of its continuous stage. The red tone is an outcome of its rather cooler surface temperature diverged from different stars like our Sun. While the Sun's surface temperature is around 5,500 K, B's cooler surface registers temperatures around 3,500 K. This cooler temperature allows below to transmit light at frequencies that give it a red appearance. However, this tone isn't just a visual quality. It gives snippets of data about the star's condition and the cycles that are occurring inside. Massive gaseous spread adding to B's persona is its genuine variety change. Old Roman and Chinese work suggest that near a really long time back, below was yellow. It was solely in the 900 years that Arabic specialists initially described it as red. This variety shift over humanity's set of experiences isn't essentially a detail. They're a psyche of cosmology, but a clue to the star's extraordinary way. The variable quality of below is another fascinating perspective. It's a semi-standard variable star, and that implies its light sometimes travels every which way. Moreover, this variability is a brand-name dance of glow that has intrigued stargazers and skywatchers for a truly long time. Regularly, below goes through a Betelgeuse-decreasing multi-day cycle alongside a more extended cycle that stretches something like 5 years. These cycles have been recorded as far back as 1836 by Sir John Herschel, and possibly considerably earlier in local oral traditions. However, what makes below truly obscure isn't just its changing quality, but its inconsistency. Not at all like many stars that follow an expected model, below irregularly diverges from its melodic reducing and illuminating, demonstrating multifaceted and less understood processes occurring inside its amazing design. Continuous Earth-breaking discoveries certainly stand out of cosmologists and stargazers in general, with a frightening and hair-raising change in its appearance, an event now widely known as the unique lessening in late 2019. The red supergiant below, perhaps the most awesome star in the evening sky and a perceptible part of the Orion grand body, began to lessen bafflingly. The star's reducing was verbalized to the point that it began losing its glow at a run-of-the-mill pace of 0.01 sizes every day, showing up at its most diminished wonder in February 2020. Below, customarily clear to the eye even in light dirt districts, ended up being extraordinarily fainter, a change noticeable even to amateur observers. However, there's one issue with endeavoring to screen the activities of Below: the time oddity. Exactly when we look at a star like Below, we are not seeing it as it exists in the present, but as it was before as a result of the time it takes for light to make an excursion to us. In Betelgeuse's case, at around 725 light-years away, the light we see today left the star nearly 7 even hundreds of years earlier. This difference makes it tempting to predict and screen unforeseen changes in a star's method of acting, as we are fundamentally looking into its past. The B-obscuring event filled in as an indication of the characteristic inconvenience and the hindrances of our cognizance while dealing with the colossal gigantic extensions and the time oddity they present. The spreading out of B's divine show was firmly checked by Andrea Dupree, accomplice administrator of the Center for Space Astronomy at Harvard and Smithsonian, and her gathering. They utilized Hubble to separate the behemoth star as a part of a 3-year study to separate assortments of B's outer climate. These insights offered unique information into the components of a variable star like Below, which reliably expands and contracts, causing changes in wonder. Hubble's antipathy for splendid light allowed the experts to test the layers over the star's surface, which were warmed mostly by the star's furious convection cells. Further assessment of the Hubble spectra, taken at different concentrates generally through 2019 and 2028, in assessing the advancement of material in B's outside environment, specifically the spectra focused in on magnesium-2 lines which are normal for the star's ecological conditions. These insights showed material moving at paces of around 200,000 miles per hour from the star's surface into its outer air. This hot, thick material eventually extended extraordinary miles from below, and was the trailblazer to the build-up cloud that prompted the star's obscuring. Dupree and her gathering evaluated that twice the conventional proportion of material from B's southern portion of the globe was lost over the 3 months of the AR corruption. This mass adversity was enormous, especially considering that Ju, like all stars, interminably lose mass, however at a rate undeniably more critical than that of our Sun. The size of this mass send-off and the subsequent obscuring began discussions among cosmologists about whether this event could be a precursor to an infinite blast. The proximity of Below, around 725 light-years from Earth, adds to the interest as any such impact would be observable from Earth and give an exceptional opportunity to see an infinite blast extremely close. However, this has yet to be T. What does this obscuring event anticipate for B's future? Is it an indication of an approaching vast blast or simply an uncommon episode in the star's long and complex life? A couple of theories were proposed to figure out this startling change. One transcendent theory proposed a phase in the grandiose blast impact process, a theory that got some respectable forward development in view of the ordinary conviction that Below is drawing closer to a marvelous completion. Another notable theory is trap dust, possibly from the real star Ophiska. Our view of Below as other red super monsters is known to shed material, and it was felt that this material could shape a build-up cloud adequately thick to decrease the star's light as per our place of view. A third explanation considered changes in the star's photosphere, the perceptible surface layer, which could impact its obvious splendor. Inside and out assessment using unique observational methods loosened up this mystery. Spectroscopic assessments showed a drop in B's convincing temperature, suggesting that the decreasing could be a direct result of a gigantic faint spot on the star's surface. This theory was maintained by the insight that B's temperature diminished by something like 170 Kelvin around the hour of the lessening, highlighting enormous changes on its surface. In the end, the approach to understanding this unusual idiosyncrasy came from humanity's sentinel in space, the Hubble Space Telescope. Hubble's discernments revealed that the lessening of below was most likely brought about by an immense send-off of hot material into space. This material formed a build-up cloud that obscured a piece of the star's surface, truly reducing how much light reaching us from below. The build-up cloud was acknowledged to have formed from very hot plasma which shot out from a gigantic convection cell on the star's surface, and later voyaged through its hot climate to the colder outer layers. As it cooled, it formed dust grains, making a cloud that blocked light from about a fourth of the star's surface. Hubble's Splendid Light Spectroscopic Insights, which began in January 2019, were fundamental in figuring out the course of events leading to below darkening. These discernments got signs of thick, warm material going through the star's climate in the months leading up to the reducing in December 2019. A couple of ground-based telescopes likewise observed the star reducing in quality, particularly in its southern hemisphere. This material, which was initially more brilliant than the star's regular splendor, over the long haul prompted the improvement of a foreboding shadow as it moved outward and cooled. The hypothesis was that this outflowing material and the subsequent foreboding shadow caused the star's sudden lessening. The size of this send-off is truly astonishing, moving below into an enormous spotlight. The star's removal moved an anticipated 400 billion times the mass commonly conveyed in a standard piece. This removed material, acknowledged to measure a couple of creases, how much is our moon, was an enormous event for below as well as for how we could decipher immanent mechanics. However, how should such a huge release of material impact below an astronomical blast hypotheses at large? The consequences for infinite blast theories are significant. Standard cognizant sets that red super monsters, like below, lose mass at a rather reliable speed before the dangerous completion of their lives. Not enduring, the size of this send-off challenges this thought, proposing a more stormy and perhaps inconsistent completion of the life stage for these stars. Could below eventually get ready for its incredible finale, an enormous blast shoot, within the accompanying several hundreds of years? Late assessments guess about the preparation of such an event, suggesting that it might be sooner than as of late thought, potentially in just numerous years. Below shock is another essential piece of the below puzzle.